Only import is taking so long. So yeah, I think I switched to 3.7 version of Python. Yeah, I have multiple versions. So it is having Seaborn. So there was one data they are talking about tip and then SNS dot I think data load data set. Yeah, some data set they have, meaning these libraries also have some data set available with them, so you can directly load tips data. Like,
This is like from which file now we are taking it.
yeah,
It's like
these
very.
library already have this data. So these libraries, what they will do is like for general, meaning implementation or for example kind of thing, you will find such these libraries have standard data set available with everyone. Each of the libraries will have such data set. I think very small data set. So what they will do is they will pre-process everything and make it clear, usable format, and you can directly access them actually.
Okay.
This get data, I think if you call this, I think they are saying you can get the list of data set available with them. So let's see. Yeah. So these are some data sets they available. So very general one is Titanic. Many people use Iris is the one data set I heard of. Rest I did not heard of. Yeah, but
Okay.
these are some tips data we are working. Okay. So SNS dot pair plot is there. One of the kind of very prevalent to used. We are doing this on before going to plot. We should check what data we got. So you just now I explained also. This is data is like some tips data. How much tip we are getting from people from restaurant kind of, and who are actually coming. Are they smoker or not? On which date? And did they come for dinner or so some correlation you want to find out like female used to give tip or not,
Okay.
something like that. Yeah. So this pair plot when we do is like what it will do, it will plot this versus tip, total bill versus tip and the remaining number, total tip bill versus size. So you can see some, I think only it will do for numbers, right?
Mm.
Numerical values. The plots or yeah, any plot will actually this distribution or scatter plot. This is it is doing for total bill versus you can see total bill. So that will have distribution only, saying that for you can see, yeah, female is the orange, right? Orange will are lighter version, meaning they are spending very less, and you can find males are spending too much. To from total bills, you can see same for tips also and size also. They are coming in mainly majority of the groups are two people size actually. So these types of analysis you want to do, you can do, and I think this when you check this right, the one this ticks are nothing but 0, 1, 2, 3, 4 number of people actually. I think yes size. So number of people they had, and in the tips also. So in this plot you can see this is the plot total bill versus tips is the one important. As the bill increases, your tip size should increase. One assumption you can have, and then try to do such analysis. So this is one plot. Your pair plot actually combines everything, meaning all possible combinations: size versus total bill, bill versus total size, tip versus. So what it will do, it will find all the numerical columns and plot the for you. And I think
Well,
you, yeah.
Wonder. It's like in the comment we didn't give much things, right? We just gave based on the sex. You have to modify. But
Yeah,
how much is taking all these things? Like,
because these are numerical values, right? Data,
total bill.
tips, total bill, and size. No, this one size. So if you do same thing with some other data set, suppose let's try with other data set. Wait here. No, yeah. Let me click here. So there is one iris data set. We can check SNS dot load data set, and we call iris. So so you will check iris has some this. Actually, this data set is yeah.
Dummy
Do
data kind of.
no, no, not dummy. It's very popular data iris. What it is some sepal length and sepal width, petal length and petal width. So to understand this, right, actually this is flower length actually. If you check somewhere, iris data set, it's very, yeah, very much used in images. Maybe we can see example. Yeah, this is the thing. So these three types of flowers actually they had, and they collected the data for them. We call this as a petal, and the bigger leaves sepal.
Okay.
And based on that, actually you can classify this flower is this type or this type or this type, Virginica, versicolor, or
Oh,
setosa. Hmm. So that is the data set we get. So they actually calculated and stored somewhere. So now when you do the pair plot, you will same you will find similarly pair plot. Actually, we should call SNS dot pair plot. Yes, and on this data set iris. So it will auto select these grids, numerical grids. So now you can check, right? Iris has four numerical columns. So it will try to plot correlation kind of this versus this versus this, and this versus this kind. All the combination. So sometimes this, if you find bigger data set, don't try, or you can try, but it will take longer time to compile this and give this result. See, you can see it's if you in this one you can find some clusters are already present, meaning this one has some correlation and this other has correlation. Maybe if you put that saturation piece on this one, what is that species, so different species of flower it is actually, and based on that the size of this increase and decreases, the petal length and this. So you can find some correlation actually, so you can clearly see Setosa is very much different from other ones. Their length are different version, right?
okay. How here? How do we understand this? In the scattered plot,
Hmm.
it is like it's pointed somewhere else. So what is this? I mean, how
You
to
have to,
understand the?
yeah,
Is it
maybe later on you can plot them into one by one. So suppose you, instead of doing entire thing in one go, what you can do, you can pass the particular length, what you want to plot actually. So suppose you only wanted to plot these two. So maybe you can directly pass here, or direct, you remember, right? Yeah, this way we can plot, give the column names, and this will plot only for this data set. These two columns. So maybe you can find easier or better. Why it is saying such? Species also. Yeah. So in this way, easily you can see I am checking versus sepal width. versus sepal length, and width versus length is very much, or yeah, these two plots are actually saying different, how to distinguish between this. Yeah, so this you have to like, yeah, based on data set you can find some correlation, and you decided to do the what to say, segregation, or yeah, make a different plot based on a species, then you can find some correlation. So these plots actually, I think Seaborn only have this pair plot very good to explain any correlation between entire data set actually in one go.
I'm able to understand the requirement, but I'm not able to analyze what is there in the graph actually.
Data or graph. Oh, okay. Graph, it is nothing. It's a scatter plot, right? So what it is doing, taking one record of petal width and putting it here versus sepal length. You remember that day we were doing X versus Y. This one, the scatter plot, this piece. So one point was 0, so Y was 0 and X was 0, Y was X square, right? So that plot only.
Okay.
So one record here, it is one by one. Is it taking 5.1, plotting this and coloring based on this? Then
Oh,
plotting this versus sepal length versus sepal width. Plotting this versus. So in this one, sepal length versus sepal length, right? So no plot will come. Actually, it will be distribution. How many points we have. So how many 5.5 is there of this one actually?
okay.
But
Can we
in
try to figure out? I mean, mark that
actually,
value
yeah,
or something.
we should have plotted the first one, this dist plot. So this distribution plot is doing is, it is plotting for only one column and checking how the entire distribution is. When we say distribution, it's like spread across the data set. So if you remember, we have tips of data and we just plotted this. So it is saying I got total bill of maximum times 20, actually total bill around 20 to 30. It was very much.
Okay.
It is like count or frequency, you can say. Remember total bills, if you check in the data set, go down. Let's first make to understand, yeah, this tips for total. So this data, right? You can see 21, 23, 24, 20 series is always will be higher because no one is going to spend too much. No one is going to spend too low.
Okay.
On general basis, you find 20 to 30 is highest prevalent bill size. That is actually total bill versus total bill. When you are plotting this, right, total bill versus total bill, it is the distribution actually. Oh, it's gone somewhere. We can plot again maybe. Yeah, here actually. Yeah, total bill versus total bill is distribution. And when we put this hue actually is equals to sex.
Colors.
Yeah, it's just different category. So obviously you can see this is one plot total bill, but you can put condition, right, saying sex is wait. I think first we have to put the condition. Remember, Oops.
It was
Somewhere.
given male and
Uh,
female eyes.
oh, okay. Yeah. Yeah. Capital MAL. Okay. So one plot is the lower version is this, and sorry, higher version is this and lower version is for female. So that is only two different color it is saying. It is distribution on the filtering actually you can say. And so what is the advantage here is like you can have this difference based on the sex in one go. Otherwise you have to do manually for each of plot. So
Okay, whatever we saw a female graph and a male graph, the both is combined into one and a differentiation
yeah,
of both is given.
correct. Here it is same actually. If you maybe yeah we can check based on the size. Yeah, actually here if density is equals to false, there is one command will you density equals to false. No argument density. Okay. What is that command? Y level is density and X level is total bill. Actually, it has one more argument which uh, in hovering, yeah, we can figure it out. Yeah. I think KD is equals to true or false. That is K distribution is false. Yes. Then actually you will not see that. Oh,
Curve.
curve, yeah, that axis. So that axis, that curve is actually doing is what it's joining this midpoint of midpoint, nothing else. Midpoint of each of the bar and trying to find you what to say uh, a shape actually, shape of the distribution. Yeah, but this one not actually. Okay, yeah, this is also helpful because now you can see this height and we are trying for female, right? So yes, so for female you can see around 20-25 we are seeing the value and you can cross validate here actually, but it's based on the curve. So around 30 it is showing the similarly I think when we say true, yeah, it will based on density actually. Yeah, so density is generally okay. Oh, please add up
What is
here.
density here? I mean, we don't have density data in our data
Yeah,
set.
yeah. Density is nothing but percentage. You can say how much percentage this data is there. So you can say this bar is around 6 point some percentage. Yeah, 6.9 or 6.7 percentage it is this data set. So meaning your bill range between 12 to some yeah we can 12 to 15 kind of is 0.6 percentage, 0.68 percentage, 6.8 percentage. Yeah, that is the idea. Or you can say 0 to this 5 around 0.5 percentage. Yeah, that data actually you can check how many count we have between 0 to 5. Then you can cross verify also.
Rishi, is there any like a common place where we can just go ahead and read the graphs? Like the graph what we read, I have read in school, it's like entirely different, and what we see here is different because I'm not able to recollect.
They
You
are
were able to
kind of
give.
similar, but only thing is they were very, you can say, easy ones. Now they are in, yeah,
Yeah,
advanced one.
yeah, it's a little bit complex. And in our
No,
graphs,
no,
we used to have the zero point 0.1, 0.2, 0.3, 0.4, point 0.5 while marking. But here,
correct.
when
Those
you're
marking are missing here. You can actually label them based on requirement. Label. And actually, here one more argument will be there. I think bin size. Yes, bins. So in that examples, when we doing in the classes, right, the bin sizes were fixed by us, and it used to comes with some maths analysis. based on data. But here actually you can change that bin size, and then you will see like this distribution, that percentage will keep changing. So suppose you took bills as 100 bins, so you can see very small, many bills, many, you can say many bins we are asking, right? So what it does is it 0 to 500, it's divided into that 100 bins and trying to plot them. So then your this plot will different, right? Because I think very small bin will have only one data set. Correct, right?
Yeah.
That is the idea, that you have to figure it out. Generally, we leave that bin size as a default value, and what it does is it takes based on the data insights and creates a better. This actually the idea is to create this curve very well, and on based on that curve.
In a real time, it's like to a client or to a user, we will represent this data, like what is there in the graph. Like that, we will be displaying it, or still we have a rework on that. Hello?
Ha, yes, yes, say you are
Yeah.
asking, yeah, something.
Yeah, we say like it is to the client or to the business user, we will be giving a visual representation. So that is a easy way of communication. So now we have a graph. So this is also a visual representation. So this is what we will be giving it to user, or still we have a rework. Still we have a lot more on that
When
graph.
you say graphs are, yeah, that is fine. Actually, what happens, right? One example is like you will later on when probability class is there, you will see there are many types of distribution. So what we have is based on the data, we have to figure out what type of distribution it is. So these data sets actually, this histogram actually help us to figure it out what type of data it is. And yeah, you are saying these are actually for us, no nothing to do with client. Because client will not asking you to find the distribution plots, he will be asking some general question. Is it really, if you can say based on this data, say, or his data set, you can directly say correlation, yeah, if your length are between this to this, you can easily say that is setosa, that is
Okay.
species. Or based on some correlation, and yeah, you can say your bill is that much amount, you will usually expect 10% or 20% of the tip.
Okay, this is for our analysis. Based
Yeah,
on our analysis, we will write a theory. Okay.
you have to do some hypothesis, that is like, yeah, for tips increases, sorry, yeah, bills increases, tips increases, and I found, yeah, more number of people are coming, so bill will be always higher, but tip cannot be higher than this amount or something like that. Or
Okay.
these types of analysis you can say. Or you can say like on Sundays we are getting many people as a dinner, so many people are coming on big size of groups, how many, yeah, percentage of big size group are coming and all. So these types of questions you have to answer. Mainly idea is like business problems will be there, you have to solve them, and based on the analysis you have to conclude, yeah, this problem really exists and that is kind of possible solution for you.
Okay.
Yeah, this distribution plot you just saw, actually a bin size here, actually they are also saying you have to pass the bin and remove the KDE layer. Maybe I can read again. And yeah, when we say joint plot, I think basically two distribution and one is like, yeah, the bar charts, or sorry, histogram for each of the data set and the relation between them, these two. So in pair plot, that is mix match of everything, but You can do one by one also. That is SNS dot join plot, and here you can pass the data sets. Uh, Data we already passed. Then you can pass the column names. What is that? Total bill, I think, and maybe this is the, yeah, okay, yeah. Total bill, and it's, I guess some column name is not missing. Total bill. Okay, let me check what is the syntax. Yeah, we can directly pass. Okay, like this. Yeah, it was saying something. And when you do this, you can see your bill is increases, like $50 bill is coming. Then you expected around $10 tip, and some $35 bill is there. So around five range of two to, you can say, yeah, $2 to $6 you expected some tip. Yeah. So these are only plots. So SNS is not helping us to figure it out what conclusion we should make. It is just helping us to plot the data in different format. One is joint plot and one was pair plot, and yeah, then this is also there. You can put kind equals to hex. So which plot actually, meaning able to, whatever you have a hypothesis, and based on that plot you can conclude or say something. So what we generally do is, on the data analysis front, we try to find some hypothesis in our mind, and based on the plot we try to prove them correct. Yeah, this hypothesis makes sense. In this also you can say, generally we are finding this bill between 10 to 15 are getting higher number of count we have, data we have, and we can say we are getting around 2 to 5, $1.5 to $2.5 of tip actually. And this is very dense data actually. You can say this area is, a lot of people are actually spending between 10 to $15, and they are spending around $2 of tip on average. You can
Yeah.
conclude something. So
Rather
based,
than scatter plot, this what is this kind of graph
yeah,
called as?
yeah, correct. This
This
plot is
is
saying dense is generally based on density also, you can say, right? It is very dense area, this three hexagonal hexagons hexagons, or yeah, pentagons, yeah, hexagons. And these numbers also is there, Pearson correlation actually, that coefficient actually, p is saying it's very significant, meaning 10 to the power minus 34. When it is lesser than 0.05, generally we say they are correlated. So you can say, as this Pearson coefficient actually, I think saying 60% or 68%, this tip is actually correlated with the total bill. Meaning, if your dollar is 20, uh, ex-
with
you
this.
can expect, yeah, 0.60% kind of tip on it. Uh, yeah, it will be around 1 or $1.5, right? So that is the idea. You have to find some correlation between, yeah, if your total bill increases, will the tip will increase or not, or person is going to pay your tip or not, and if he is going to pay, how much it is. So you can say this line is actually representing a relationship between y is equals to mx, we say, right? One linear equation line. So the idea is, if I give you total tip, total bill amount, will you able to predict how much tip I will be going to get? That type of business problem can come. And you just saw, right? When, yeah, this one is kind of equals to regression. I think this is the final topic, regression topic we call it. You have to find some relationship between numerical values, very prevalent in machine learning, only finding such relationship. And I think this is a equation, or we'll check what is this. So you can see, this is, there is a straight correlation. As your total bill increases, tip is also increases. And they can have some range also, they are saying. And you can plot these graphs actually using and conclude something. Yeah. Palette
Sure.
actually is
One
nothing.
more time.
It's just a type of what to say, color. Yeah. Ask your doubt.
Yeah, here there are so many graphs. Like there, I could see a bar graph, scatter plot, and that hexagon, and there was a line. How do we decide like which graph we should be taking as an approach or a first level of approaches, or should we do everything? Every graph we have to try and then see what it is.
Yeah, both way is fine. First way is like, if you have some hypothesis, try to conclude based on some graph. Other way around, meaning have some hypothesis and try to prove that hypothesis based on some data. And second way is that try all the plots and conclude something from those plot actually. So usually you will see, usually you will get this numbers, right? Based on number you cannot conclude anything, right? If you see entire data in one go also, or one day, entire day spend this only reading, yeah, female spent this much, then tip was this much, and day was that, but you cannot recall everything. So it's better you try to plot them actually. Yeah. So what we generally step will be, try to plot one by one. Yeah, check how much people are spending. So you will, on based on this data, you will try to find max and min, how much maximum people are spending. Then you will try to conclude, yeah, is female are spending more or male are spending more. Then you can check on tip how much I am maximum getting tip, minimum I am getting tip. So it will be like that actually. You will be going one by one and trying to plot them, and based on some plots you will conclude something. So general step is that, I think, we try to, you have to do analysis, right? In the end the client will only give you that exe file, CSV file, sorry, not exe, CSV file or some data, but you don't know what the data has. So you have to figure it out and try to plot which plot makes sense, and conclude something based on those plots.
Okay, and here if you're giving
Plot
that
is
this plotting, it will give the same value, right? Either whatever the graph we choose,
correct.
finally the output will be the same, or it's like again based on the graph the output also varies.
No, no, no. Graphs will be same. Why graph will
Okay.
vary? It depends on
Okay.
how you want to use them. Yeah, what kind of data you have to plot. So
No, that was
data
my
will
doubt. It was like since we are doing that axis changes and the bins changes, something got split up.
No, no, data will, yeah, that bin size when you are defining, it is actually doing, changing the group, right? Yeah, and categorizing. Actually, there will be one command actually which can tell how much is the bin. What is the bin actually? So here, this one, tip one is better one to analyze and understand. But this one you can say straightforward. These are actually example, right? So they have some pattern already. But in your data
Okay.
there will be no pattern, or you have to figure out that pattern.
Okay.
Then you have to actually, in the end, what you have to do is do lot of plotting and trying to figure it out which plot makes sense, and do some analysis. So yeah, that is the idea. We also doing some analysis, we end up doing multiple plot, many plot, and which plot actually going to work, we are also not sure. So it's good practice. That is why this pair plot I told, right? It will just call on the data set based on some graph. If you have, you know that cluster is there, a group or category is there, you can directly call them and have a plot, and then try to see is there any correlation. You can see there is no correlation actually. In this one, petal length versus petal width has some correlation, and I think similarly sepal length and sepal width will have some correlation or not. Yeah, but obviously width versus width cannot be having any, should not be having any correlation kind of thing, you can conclude. You can see this is not correlated at all. So that is sepal length versus sepal width. Yeah, because as width increases, your length is increases or not. That is the idea. You have to figure it out. Here also, I think, but here actually you can see petal length versus petal width. As length of petal increases, width of the petal also increases. You can say something. That
Okay.
is the idea, and you can clearly say they that petal. This one, this setosa group is kind of always different from the other two, right? Yeah, this one, versicolor and virginica. The two types of species of that same flower, actually, I think, and it's what to say. What the question will come, right? The actually the question is, if I give you some measure of this all four sepal length, sepal width, will you able to predict the species of that plant flower or not? That is the question actually in this iris. If I give you four or five random numbers or random data of this, will you able to predict correctly the species?
Okay.
And you can see the figure of just now you saw, right? We search iris data. Those
Yeah.
three plants actually looks alike.
Similar. Right.
Yeah, you cannot distinguish actually. That is the challenge they found, and that's why they bring this problem into machine learning. Will the machine learning or this,
Predict. Correct.
yeah, they can predict or not? You can see they all three are looking same, but they are three different species of the flower.
Yes.
Yeah, you can say three flower species. So these types of problem you also want to solve. So one example can be is sometime you have to based on the size of the anything, what to say, this flower or fruits. Will you can you guess, like, is it raw or ripen?
Okay.
We got such problems. I think some people are solving, or you can categorize them, right? Yeah, these are big flowers or big size fruits. I will be selling at higher rate, and that is straightforward if you find. But is it ripen or not ripen? That question will come into machine learning. Yeah. Raw, or it's fully grown or not fully grown, kind of. Yeah. So these are some plots. I think in this example they have pair plots. We just do regression plot. I think this one is very simple concept. Just draw dash univariate distribution. Okay.
Okay. Instead of bar graph, this is like a for a barcode. How the different.
Percentages. Yeah.
Actually, can we have images like for images also? Can we do plotting, or it is like only for the numbers?
Yeah, yeah. Images
Like
also you
uh,
can do some plots. There will be different types of images. Actually, you will what to say. You will convert them into RGB format image in matplot, I can say, or image in Seaborn. You can check.
like if we have two images, like how we have a game like a find six matches or six differences kind. So those kind of things that we can do it in the
I didn't get
graphs.
how you will get images.
One second. Now we have this very versicolor and setos are right.
Hmm.
So for this, if a user is giving or is a task like they just give this two image and they're asking like find the differences and find the similarities between these things.
Ah, yeah,
So
that is
is there a
image processing. Yes, CNN. Hmm. That is actually
okay?
image processing. You are talking about image recognition, kind of. Yeah,
Okay,
this
that's
one.
a different process or a
Yeah,
different topic altogether. Okay.
in images also we are doing machine learning, right? If you saw on your this one photo, Google Photos actually. They actually, if you search on the Google Photos, like I want dogs images, it will actually come up with the dog only. Yeah, YOLO V5. One classic model is going on in this. Actually, what it does is, where is that example I can show? Inference detection. Okay, train custom multi GPU. Yeah, I think documentation will have here tutorial. No, 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 no.
I mean, the question which I asked is valid or I just got it
Yeah,
wrong.
yeah, yeah, correct.
I mean, like,
No, but
situations.
yeah, you might be not solving such problem because that is classical image recognition problems, and people are solving such problems also. Oh, okay. So I think some scripts. Yeah, the example is there, but I cannot see actually. Can show you tomorrow maybe. Yeah, these are the some plots we talked, and after that, I think yeah, you can similarly plot the Rix rug plot and KD plot. KD is nothing but distribution percentage plot, and then density distribution percentage. And rug was nothing. It was just I think yeah, this data set actually makes sense. Yeah, this one rugs. Rugs are actually very simple concept. They just draw dash mark on every point on univariate. So based on this density, you can say how much. So based on the see data, you can say $10 to $20 or $35. Many people are actually spending, and remaining amounts are very less. That is, yeah, I think why the dash. I, if you saw some client this graph, he will also laugh. You will also laugh. No point of showing such graph.
Here
So
in this Seaborn, can we have that labels and legends? Like,
yeah, yeah,
uh,
correct. So for that also, I think there will be some thing will be there, but obviously these sepal length and sepal width somewhere it is coming, and I think if we hover it, yeah, I can see anywhere it is written properly. No, not it will return pair by pair. Okay, pair plot will not have such feature. Maybe we can check for this distribution plot, but in general, yeah, you can see label and X label and Y label also way there probably. Yeah. So label is you can read labels are string, and I think it is for entire this label, and you can pass this X label is this, Y label is this. I think by default it is taking density and total bill. And similarly label is for the total plot also. So maybe we can try label and saying best plot of total bills. Okay. Is it coming somewhere? No. Why? And they are saying dist plot based on dist don't use haste.
function.
Yeah. They are actually saying, yeah. Where is that? Yeah, this piece is not coming.
We don't have a count, but something called count is coming. Okay, it's a Y label name they are given by default.
No, no, why? Because we changed this to haste plot now.
Okay.
Previously it was dist plot, distribution
Yeah.
plot. Now histogram plot, but why labels are, oh, legends are equals to true, we can say. But legends are different, right? Yeah.
Ah, it is
Yeah, saying values, right? Yeah. Oh, still, I think, yeah, there will be some command. Only thing is,
okay. For this only they use matplotlib. There it
yeah,
was little bit easy and understandable.
yeah. Only thing is, it's a new, I think, late, recently introduced, maybe not too old. That's why it's very hard to remember this. Matplotlib is actually very convenient to understand because they have copied the idea from this MATLAB, and I think MATLAB was very prevalent that time. Yeah, and it's also easy. Okay, I think we can figure it out later. Labels,
Yeah,
or you can Google also. Yeah, yeah. This is the, I think. hmm, Oh, sometimes yeah, they are not answering on. So these actually, I think they are actually built on top of matplotlib. So same commands actually you are using. Yeah. Hmm. Yeah, correct. So you are defining AX equals to this and saying ASX part and all. Yeah. It is similar actually. No need to, yeah, worry much. So let's quickly check this categorical plots. I think these are only for some category data. So bar plots, you can, based on sex, you can do the bar plot. How much total males, I think mean it is of total. Let's try this, yeah, because if we don't try, we will not experiment. Yeah. And we experiment, we learn more. Yeah.
yeah.
SNS dot bar plot is there, and we are plotting x is actually, yeah, this I in this you have to explicitly mention the x is total bills, y is, I think, y is 6, and in this data actually you can mention tips. So x and y you are giving column names, and data you are passing entire data. Let's see, is it working, not working? Could not interview. Okay, total bill maybe, not bills. Yeah, and you can see it's similar to that matplotlib, and this is total actually. I think, yeah, total female actually spend around $17, and some males spend 21. That is the data on the bar plot we can get. Think, yeah, same data, but why it is coming in this format? Okay, sex was there, and the x was x, and total bill. Yes, correct. And this is not mean actually. Right now, this is bar plot. So it is total, and on average, you can see here what is.
This hyphen on the top of that, it is a part of
Yeah,
the bar plot diagram itself.
correct,
We are
correct.
not doing anything, right?
Yeah, yeah, we are not playing with that. Yeah, and you can see this is kind of matplotlib only.
Yeah.
So these graphs or new packages, they build on top of matplotlib. So they will use some functionality of that and figure it out for you actually. And meaning build for you also. This is bar plot. Similarly, I think you can change estimator object and convert the vector to scalar. Okay, don't know what they are doing. Oh, estimator actually. Okay. Let's pass this one more argument estimator. Okay. NP dot mean and dot numpy as NP. And this should no, not much difference, but don't know why it is not. These are some. Let me check how count plot is different from the bar plot. Count will actually count how many males are there, how many females are there. Mhm. Okay. Same explicitly count the number of occurrence. We only pass x value. No need to pass y. It will count based on that. So
This is just like how many male and how many female, right?
correct, correct. Yeah. That one actually giving mean of that. Oh, okay. So that was giving mean how much percentage they are actually $20 on average or $21 on average. And this bar actually is saying probably on average that is the range. Maybe it cannot say this is min and max, right? Min can be 0 around or 10 5. And we'll check what is that hyphen at the top or black dot. And I think some more plots are there. Same counts you just saw. And
Hello, Rishi.
yes, hello. Oh,
I think your screen and voice is stuck for me.
now also.
Now it's a bit.
Oh, okay. Similarly, box plot, if you remember, we talked about box plot is like this midline is mean,
Mean, median.
third percentile, and first quartile, and min and max, and these are some outliers, top ones. And these are very helpful. Actually, you can see as you see your days are actually from Thursday, Friday, they are very lesser means, right? You are spending very less on total bills. But as Saturday, Sunday comes, little higher is expected. You can expect.
Right.
So this you can try actually box plot and put data on day. Actually, you want to do that axis. X axis is nothing but based on the date or day changes and total bill or total tips also you can try actually. Let's try for total tips. Is it in the same pattern or same way it is going or not? So these types of analysis actually we do many actually try to figure it out some correlation or you can say yeah this is correct or what is the
Tips is the data name, right? They have taken column name.
column name is tip, right? Yeah. So you can say on Thursday you are getting very less tip on comparison to Friday. Even Fridays are higher than other two. I think yeah comparable to Sunday, but Fridays tips are higher than Saturday's tip.
Saturday
You
and
can
Sunday.
conclude kind of. So these types of analysis, they are actually helpful. These plots, and if you do the plotting, it's very good to visualize yeah your data. So these are some tools. For this box plot is on Matplotlib also, but they don't make very. And similarly, you can do here this command orient is equals to orientation, nothing but horizontal or vertical. then this axis will change. You can actually look into different actually. Oh, okay. This is actually doing for can do for entire data set also. So you can say comparable to total bill, tips are very less actually, meaning where your what to say bills are around 20%, $20, tips are around $1 to $2, and your size are very less also. So it actually checks all the data set, whichever numerical value, and try to plot them actually.
This is like a overall.
All the data, yeah. Similarly, you can try for this, this one, sepal data and all. Just Control A, Control C, and try to plot for box plot for entire data was mhm, iris data. We can check how it is. So you can check your sepal length with comparable to here. You can see petal width are very less comparable to sepal width, and sepal length are higher than petal length. Such kind of analysis you can say and conclude with. Yeah. And yes, so these are only plots you can play with that. Similarly, you can bring this uh, group also for smoker versus non-smoker, maybe male versus female also you can try. This is one more actually Wheelian Voilen plot, uh, similar rule to box and whisker plot. Just quantifies actually same thing but in different format. Only thing is kind of density data it is. So you can, if the width is two increases or decreases, you can say it is different or not kind of. Same plot generally, I don't use this much.
Uh,
People
it looks
also.
like a non-familiar plotting way.
Yeah, this is same actually box plot only. But what it does, it's try to have a density kind of thing. So you can see mean are very much in the data set, but top, the first quartile and the last quartile, they will be very less. And based on the shape, you can say spread of the data actually. So the shapes are for this Saturday, it is you can say it's in very high range from $60 till $60 from zero. But on the Thursday, it is around 50 only. Thursday and Friday. But on Saturday, it is quite high actually. In even though it's higher than this. But on Sundays, you can also conclude they are actually maximum spending it between till $30 or maybe $35. You can assume saying like yeah 70% or 75% of the people are spending till $30. But on the Saturday, you can say it is around 20 $25. Such such numbers you can make, and based on the data set you can say yeah it is same actually. And similarly for male and female also you can check. Female are generally spending between this on Friday 0 to $30, but males are actually spending 0 to some $50.
Okay,
So
all the overall the graph changes in the place where we are defining it. That's all.
yeah, correct. So you have to what we do is we try to plot maximum what type of plot we know and try to make one conclusion out of each plot.
Okay.
And you can say, and in the end you can find overall conclusion. I think similarly you will have this uh, strip plot and swarm plot. These are also nothing but I think just same representation in different way, I guess. So yeah, strip plot is nothing in the one axis, just plotting all the points, right, how they are spread across in the one axis univariate data. But some plot is I think, oh sorry, this is also jitter is equals to true It's actually spreading if they are finding multiple points. And this is also same. Yeah, just distributed.
based on
Sorry.
color.
Yeah, based on the sex, male or female. And I think, yeah, strip or zitter is true. Then you can see two different, male for female for different. These are actually, yeah, this is actually swarm plot.
This looks funny actually.
Yeah, these are generally you will conclude your conclusion till this box plot only. You can,
Okay.
it's only variation in the sense how you want to visualize them. You can actually, based on all the last 4 5 plots, you can conclude only one thing, right? You can say
Yeah.
males are coming very much on the Saturday. That
On
is
which
very,
day and yeah, right.
yeah, kind of. On Saturdays, they are males are very much high number of people are coming and they are spending around this. On Sundays, I have very little. To conclusion, I will actually, if I get this data, I will try to conclude on two things. One is what is the general pattern of the male and what is general pattern of the female. So you can easily conclude males are very much coming on Saturday and they are spending around 20 to some, yeah, $35 kind of. On the female, you can see they are generally occurring mostly on Thursdays. They are even higher than the male and they are spending around $20 or $15. That's all you can conclude on these plots, yeah. And you can say Fridays are very less occupant kind of, or less, but that is not the case. I think just data, based on the data we can say on Friday very less people are coming, yeah. I think same plots you can combine also in the same axis. Yeah, and if you want, you can do it. I think factor plot is, yeah, factor plot is same plot, but it's generally doing on the two different. I think, yeah, based on the sex, it will auto decided, yeah, which plot to be having. Two different plots of the kind. Oh, based on the kind actually. So you told the bar plot I need, it will try to plot for you bar. So in the end, you have to try with all the different formats of plots and try to conclude something out of the data. Yeah, I will